So now I can see the brain of the patient, and you already see this red area. This is the tumor that I want to remove. And now the physician would have the ability to walk around in the operating room and look at the patient's head from different views. Hi, my name is Ben. I'm working for Microsoft Research in Cambridge, United Kingdom. And I'm showing you an application for the Kinect Fusion system where we believe this has potential for medical applications. And I'm showing you a medical augmented reality system which could be made his way into the operating theater. So what I show you here is, imagine this is a patient's head into the in the operating room, and I need to do some surgery on the brain. So what I have here is a regular Kinect device, a sensor, which you can buy in the stores. And we just attached like a USB-powered touchscreen device, which enables us to see from this position, basically the world, as you would see it from the sensor. The problem is that the scan that I usually take for diagnosis and surgical planning, where, for instance, here I see a tumor that I want to resect from the brain during the surgery. The problem is always, how do I get this information, which is 2D and on a screen mounted on the wall, for instance, how do I get this information into the operating theater and basically in situ on the object that I want to perform the surgery on? So what we built here is a system which builds on top of the Kinect Fusion, which does 3D sensing of the physical world. So basically I can quickly start a scan and move the camera around and get a 3D capturing of the 3D geometry of the patient scan here. So once I've done this, I can load up the scan that has been taken previously before the operation and where all the planning and the diagnosis was done. And when I bring these two close together, I can register them, and you see that the virtual 3D model and the actual 3D world merges into one view. And now if I show you the real world, this is what we call augmented reality. So we overlay a virtual object onto the real world, and you can see exactly on the tablet what I would see with my normal eyes, but I also get the information from the 3D model. And now since I have all the information from the medical scan, I can, for instance, remove the skin and now start to look inside the skull without actually opening it. So I could, for instance, see the bony structures here. But actually I'm interested in removing the tumor region. So I can also remove this bony structure. So now I can see the brain of the patient. And you already see this red area. This is the tumor that I want to remove. And now the physician would have the ability to walk around in the operating room and look at the patient's head from different views and basically decide what would be the best point. How do I get this red area here without destroying any important blood vessels? I mean, this is a very simple construction by duct taping a screen onto the depth sensor. But of course you could imagine that there will be devices at some point where these kind of sensors are already built in some kind of tablet-like PC.